All right, so we will move on to our final segment of this chapter, and that deals with polysaccharides, because as this had progressed, just think of what you have learned so far. One was taking a railroad tracks or your Fisher projection formula and drawing out a monosaccharide. Then we moved on from ketose and aldose sugars, and you could say move on to the disaccharides and linking those together. That is now in the past or behind us. And then now we finally move on to that of the polysaccharides. And for the most part, we just deal with two of these, maybe three. And is there any chance you can think of a polysaccharide? They're in plants. Cellulose is one. That's the tougher of the two. So you got the hard one out of the way. So yes, cellulose was the first one. And let's say, for instance, last fall, you have a home volleyball match. You want some, well, the quickest burst of energy you can get is from maybe a candy bar like Mars or Milky Way or Snickers or something like that. That would have lots of glucose in it, but this glucose repeating pattern is more so of what you would find on what we had for dinner on Monday. So what polysaccharide might that be when we talk about chicken Alfredo? Okay, so you have the sauce, you have the chicken, okay, but then you have the pasta. So then the pasta is the key. What's that? Yeah, it's carbohydrates. But what polysaccharides? Lots of what? Just like potatoes and potato chips, there's this polysaccharide. You're going to hit yourself in the head and say, I knew that. Starts with the letter S. Starch, yes. So starch is one polysaccharide that we spend time on, and cellulose is the other. And what they have in common is they're all repeating units of glucose monomers or monosaccharides, however you want to mention it. Okay? The reason we say that is going back to, let's say, if we have these two, if we make this disaccharide, and we're going to change it to a polysaccharide here in just a moment, okay, is, I got to make sure. So I'm not the best at drawing these when, see, now I got a 5-side figure instead of 6-side figure. Okay. There we go. And then if these were two glucose monosaccharides, which we're going to say that they are, okay, where does the OH go on this one, on the second carbon? Yep, because it's right. Don't know about the third one, okay? And then what are we going to put on here? Okay. And then what are these two right here then? Yeah, that's the position. Yeah, I mean, what had happened is we had this, but what's still on top here? Oops. Yeah, still have hydrogen atoms up there. Yep. Okay, so we still have hydrogen here and hydrogen here, and then we just copy this over. That's not right. Okay, so that is one distinct disaccharide, and this one would be another one. So what do you suppose we're illustrating when we do this instead of that. Yeah, so this is an alpha 1,4, where this is a beta 1,4, okay? But what happens, okay, again, this is a little more tricky to draw. Here again, we've got a hydrogen there and a hydrogen there. And we'll just go ahead and put him down. Okay, so we have two distinct disaccharides. This is a glucose molecule. This is still a glucose molecule. So is this one. And then so is this one. Okay. Now, if I remember correctly, even though these are all glucose molecules, the difference is in between how they're linked. So in this case, if I remember correctly, this one was maltose, and then this one was cellulobiose. Okay, just let me quickly confirm that before we write anything down. Okay. Yes, that would be correct. Yep. And then what would happen if we had glucose here and galactose there? Do you remember what disaccharide that might have been? It's in milk. Yeah, that would be lactose, okay? So the difference in between all of these disaccharides, for one, is how they're linked, okay? And two, with what's actually being linked to them. Now, here's the difference between what we're referring to as disaccharides as opposed to polysaccharides, is this would just keep on going. That's all that means, is we link this again to another one, okay? Then you write another glucose molecule, and then another one, okay? And what that means is this repeating unit right here, this polysaccharide, is starch. Okay? And I really can't keep going with this one. This one would be cellulose, because why can't we, I mean, we could keep drawing it, but what's going to be the problem with this? What's it doing? It's going to go up, and we'll eventually run into this. What this means is starch is just a polysaccharide that winds itself in this type of circle. Cellulose, on the other hand, is one that wraps itself around in a cylindrical circle. And one of the reasons that that's so important is just because that's what allows plants to be able to stand up in such high winds, if you want to call it that. What would be, especially you could say trees, having that cellulose structure in there. With some of these, whether they're gymnosperms or angiosperms, we see a lot of these pines and spruces out here, the naked seed reproducing plants. Then we see some of the deciduous trees, which are probably going to be your oaks and your cottonwoods. Okay, the reason that they can stand so tall and handle so much wind is because of this structure here, this cellulose, that just wraps itself around in a three-dimensional circle. Okay, now that's spiraling up. This is also, I suppose you could say, a three-dimensional circle, but it's just winding around like this in this type of a circle, where cellulose is winding upwards like that. Okay, and that gives plants, again, its ability to stand up in such high winds and be durable with where they're at in the ground. Okay. We didn't have a whole lot to go over. That is it. Just want to, again, just explain the difference between these two major polysaccharides. Cellulose, which is a beta 1,4 linkage, and starch, which is an alpha 1,4 linkage. Okay, that's all I've got. I'll catch up to you next time.